streams and files. Welcome back, everybody. Let us look on how we can interact with the standard input in JavaScript. So we'll be looking at what are streams in Node.js, the different kind of streams. We'll be looking specifically at readable streams, and finally we shall get to the juicy part, and that is working with the standard input. So welcome along for the ride. So what are streams? So streams are an abstraction on where data is to be written or read. So this could imply a stream. A stream could represent a file, it could represent a request, it could represent something like a response. So behind the stream there is the underlying implementation. So for example, if you're reading data from a file, so the file would be the underlying representation of a stream, and so have you. The different kind of streams in Node.js, we have readable streams, we have writable streams, we also have other kind of streams, but we'll focus on these two, and specifically readable streams. So readable streams can be in two possible states. They can be in a paused state, or they can be in a flowing state. A stream in a flowing state implies that the data is being released or sent to consumers automatically. A readable stream in a paused state implies that the data from the stream has to be invoked manually. So you have to manually ask the stream for more data. Now, when you do create a readable stream, it is always in a paused state. Also, a readable stream can be in a paused state if, for example, that stream has been paused, or if you are using the pipe function. That is something that, if you guys would be interested in this topic, is something we can work on down the line. Alright, so a readable stream can be in a flowing state when, or if there are any we call them data handlers that have been attached. This is something that we shall see later. The other kind of streams are writable streams. Essentially, they are an abstraction where you're writing the data. So if you guys are also interested, we could see more of writable streams down the line. All right, creating readable streams. So our scenario is like, we do have a file that contains information about bananas, and we'd like to process this file one record at a time. So what would be the best way to handle this? Interstreams. So if this would be our visual presentation of our file of bananas, maybe this file holds some records about bananas, and we're interested in processing or transforming or getting some information from this file. So we could go about this in two ways. One way would be to read the entire contents into memory, and the other method would simply by reading some few bananas at a time. Obviously, the downside of reading all the file into memory would mean if the file is too large, will in fact come into a problem. This is something we shall see. So the best approach would be, if you're working with larger files, so if you have a very large file of bananas, the best way would be to read the file a few bananas at a time. All right, so before we jump in and go to the juicy part, and that would be seeing the standard input in action, let us investigate these two methods. First things first, so we have two ways of looking at this. One, we can read the whole file into memory. So that's our first method. To do this, we gonna require the fs module. We are using Node, but the Node we're using Node runtime, by the way. Alright, so to read this, to read our file into memory, we will simply read file method here. Then we provide the path, which is banana.txt, and we can provide an object here to specify the encoding. In this case, we prefer to have UTF-8. Lastly, we have a callable. This callable accepts an error object as well as data. Let us check if there is an error. If there is an error, we shall call console error. This will be error. Yes, we shall call. Let's just use the curly braces to make things easier. S. In this case, we shall echo back to the console the contents of the file. Alright, that's the first method. Simply run this. Simply call node banana.js. Alright guys, I think you can detect a minor detail. For example, so this file is almost, I don't know how big the file is, but it contains 10,000 records. So if this file was a huge file, like let's say a gigabyte, 10 MB, and what have you, this would imply that because we are loading everything into memory, we run at the risk of consuming too much memory, and if you are constrained by memory consumption, this will be a problem. Enter method 2. So instead, let us now attempt to read a file one at a time. To do this, we will need to create a readable stream. As we have learned, a readable stream can simply be created by calling the create read stream, and then we simply provide the name of the file. In this case, it's banana. Alright, then let us set the encoding on the stream by using the set encoding. Let's call the streams do have a set encoding method. Let us look at this really quick. Yeah, set encoding. Alright, back to file. Let's make this into a constant. Stream.set encoding, and we will set it to UTF-8, because otherwise read streams will return to you a buff object instead. Alright, so we have learned that a stream can be in these two possible states. A stream could be paused, a readable stream could be flowing, but by default, whenever you create a readable stream, it will be in a pause state. Therefore, a stream in a pause state means we have to manually request that the stream. A stream in a flowing state or flowing mode means that data is automatically provided. So like data is provided to the consumers automatically. So in other words, the stream is being invoked automatically to provide the data. In order for our stream to be in a flowing mode or in a flowing state, we simply have to attach a listener. Specifically, we need to listen for the data event. whenever a data event listener is attached to our readable stream, then the stream will move into foreign state. Alright. However, if this stream is paused, then the stream will be in a pause state. Or if the stream was created, then the stream is in a pause state. So we look at a stream in a foreign state, and then we shall come back to a stream in a pause state, and now to read data from a stream in a pause state. Alright, so back to our code. In order for us to automatically invoke data from the stream, all we have to do is to register a listener and specifically listen for the data event. So readable streams do fire a data event, meaning that whenever data event is being fired, data is being set from the stream. Alright, so the data event accepts a listener. This listener will take in the data that is being provided by a stream at that particular time. Therefore, in our case, we simply echo back that data. Like I said before, if you don't specify the encoding, what will be returned is a buffer object. So let's run our code again. In this case, we no longer need this, so press delete and then we run the code. Okay, we do have a problem. My apologies. There you go. So we were reading one data at a time. Okay, moving on. So instead, we could maybe comment this out. So like I said, we have learned that whenever a readable stream is created, it is in a pause state. If a stream is in a pause state, you have to manually request data from the stream. So you can manually request data from the stream using stream.read. So read will manually request data from the stream. You can also specify the length of the data that you want to extract from the stream. If you do not provide this, so the read will attempt to provide the available data as it's been released from the stream. Now, whenever you use the read method on this readable stream, it fires an event known as the readable event. So if we can comment this, sorry about that. So whenever you use read, we have a readable event that's been fired. So whenever a readable event has been fired, it means we are manually invoking data from the stream. Alright, so all you have to do is whenever you call the read method on the stream object, one thing to note is that the read object will return, if there is no data to return at that particular moment, the read method will return nil. So in this case, we have to check for, so first obtain the data by calling stream.read, then check if the data being returned to you is not actually null. If it's not, you can now process whatever data was sent to us from the stream. And therefore, as long as we're using the read method, this event will be fired again. Alright, let us clear our console and then I'll just run the program again. There you go. Alright, we have a problem here. It says data. Okay, my apologies. This is supposed to be check. Alright, let's clear the console again. Run one more time. There you go. So these are the two ways in which you can use readable streams. Alright, having learned all that, we now know the best way if you have a very large file is to use streams. Now to the juicy part. the standard in. Can we use streams to work with standard in? Yes. In fact, the standard in is indeed a readable stream, and what we've learned so far can now be applied to the standard in. You could either use the two approaches that we have just seen. So let us now create a program to demonstrate this. So what will our program be? All right, so our program will grab a user input, then it will perform any necessary parsing, and lastly it will check whether the input from the user is a prime number, and then echo that result back to the user. All right, so we need to grab user input. Do this first. Let's create a function to check if a number is a prime number. So this function will take a value n and to simply check if a number is a prime number. We know a prime number has only two factors. That should be 1 and itself. Therefore, 1 and 0 are not prime numbers. Obviously, if n is less or equal to 1, we return false, meaning it's not a prime number. Otherwise, in order for us to check for a prime number, we have to go through all numbers from 2 up to but excluding n, and see if n divides n of these numbers. If n divides n of the numbers, obviously it will no longer have two factors, therefore it's not a prime number. But if it doesn't, then obviously n is a prime number. This means if this for loop executes successfully, it means n wouldn't divide any of those numbers, and therefore it is actually a prime number. Otherwise, we have to check. So to do this, we could simply begin from 2 all the way up to, but not including n. Post increment I, and then simply have a check here. So does n divide any of these numbers? If n divides any of these numbers, our loop will terminate early and return false. All right. However, we're gonna have a main function. So the main function, sorry, I thought we were in the Python. So let's create a main function. This main function will grab input from the user. Remember, the standard input is the stream. To access the standard input, we use the process object, then standard in. We know this is a stream, and therefore we listen we use the second approach here on the pre-data event, and then simply provide a callable. This callable we will receive the data from the stream, and then we can do the necessary processing here. Remember, we grab input from the user. Now we need to perform any necessary parsing as required. All right, in our case, we need to make sure if chunk is actually numeric. Guys, I don't think so. If I do remember, let's see if we use number. Or maybe we should use the string. If we use string, a string object, can you check this? Is there a way to check for if a string is numeric? Okay. So my editor, I believe this is a buffer. Remember guys, we said by default editable string will return to you a buffer. So we have to set an encoding here and make it to be UTF. Just like this. So chunk is supposed to be a string, but guys, can you, I'll read this to you. I don't remember, but like, how can you check if chunk, which is the string, how can you check if it's only a numeric string, like it doesn't contain, like, say, white space or any outside character other than numbers? The easiest, we could use an array and then check. You know what, I leave that to you. Anyway, so you perform the necessary parsing. So let us assume would say to do, say, checked if chunk is a, so in this case let us assume that chunk isn't in the number, and if it is a number, we now check is it a prime number. So let us pass the result here to is prime, and then simply passing chunk, assuming that chunk has been passed and it is in fact a number. Once that is done, let us now print back to the user. Let us echo back to the user and say, okay, you typed, let us echo back what it types, which you typed, let me say you typed the number chunk. Is it a prime number? Then the result, is it a prime number? With this done, all you have to do now is to simply call the main function, and we're good to go, and we're golden. So let us clear the console one more time. This will be node, okay, node input-nodejs. So this is because we did not eliminate this code here, so we are still reading the banana file. But then, as you can see, the standard input is waiting for output. So I start with 2. Okay, we have a problem, and I think it's a typo. Did I not change this? My bad. Anyways, we can leave that as is. Let's clear the console, run the code again. 2, yeah, you type the number 2. Is it a prime number? True. What about 23? You type the number 23. Is it a prime number? True. What about 2444? This is still even, right? So you type the number, yes. Is it a prime number? False. Okay, let's finish with 989, maybe 743211797. You type the number 98741. Is it a prime number? The answer is false. So that, guys, is a simple program on how we could interact with the standard input. Yeah, that's it. Thank you so much. You can click the links that will appear either on the top of your screen or down below to check some of my other videos. And if you guys are interested, next time we could journey into the Golang file system API and see what does Golang do. Thank you, and see you soon.